Record. Okay. Any questions about yesterday's class? Anything from modules, package, context managers? Anything to kick off this session? Nope. Okay, that's good. So basically, we have to cover decorators again. Decorators are something challenging to understand if we like challenge ourselves how functions and objects work, right? As I told you before, if we just let our mind free, they will make sense because they are just functions invoking other functions and actually modifying the behavior of other functions. So as we said, decorators will let us inject or modify code in our functions or classes. Basically what will happen is that if we have a decorated function, when we try to invoke that decorated function, we think, or we will be thinking that we invoked the function, but actually we will be invoking something else. So let's start with a simple example. I'm actually going to borrow these from here. And we're going to see how that works. Basically here we're creating a decorator. It's only in arguments. As you guys remember, we had a function sum that could sum to things. Of course, it can sum to integers, and it can also sum to strings. So we wanted just to accept integers and reject any other type of object. So we have created a decorator named only in arguments. I think this is pretty obvious at this point, but this is the decorator, right? Applying the function in this way is what we do to decorate the function sum. I'm going to change the name here. This is a really poor name, I'm sorry. And I'm going to change this to also do return instead of print. So in this case, we have a few things. We have the only int arguments decorator, and the only int argument decorator is receiving another function inside. I'm going to go ahead and remove this decorator, and I'm going to explain how decorators work without using the decorator, and it's as it follows. You guys know that add, in this case, is just a name to refer to this function, right? Python is storing this function somewhere, and when we do add, it's just a name pointing to the function stored somewhere in memory. So we can, for example, do something like add equals 5, right? So if I try to add 2 and 3 here, and let's put something else here, 9, this is going to fail because add, even though I have defined add as a function up here, when this line is run, the name add is now assigned to the value 9, and the function has been lost, right? So in this case, of course, the error that I'm getting is that I cannot use an integer as a function, as a callable, right? So if I can rename add, right, I can change what add means. That means that I can put whatever I want. So for example, I could cheat here and do something like subtract. Whoa. And I could be a troll and do that add is equals to subtract. So in this case, what I have is that I think I'm invoking add, but somehow, well, not somehow, I just changed the definition or the value where add was pointed a few lines above, right? So you follow me here. I'm just renaming. We're not talking about decorators. I am just renaming add. I'm not renaming add. I'm changing what add means. What is this telling us? Again, functions in Python are just objects, and we can treat them as regular objects as we do with integers, strings, as any other object in the language. What does it mean? I could do something like, for example, I could wrap all these things in a function. I could call it, for example, throw function, right? And it's going to return subtract. So instead of doing this, I am changing this a bit, and I'm just doing add is equals to the result of throw function. I am invoking throw function, right? I think this is pretty obvious, but I am invoking the function. So what it's the value that add is receiving is actually subtract. So these two lines, line 15 and line 16, are actually the same thing. All right, so let's run it again. And as you can see, -1, add now subtracts things instead of adding them. Okay, makes sense?
Yeah.
Cool. A decorator will be just this thing. A decorator will be a function that completely changes what we believe we are having as the original function. All right, so if you guys check the definition of this function, it looks a lot like this throw function we have right here. It's an outer function, and it has an inner function defined inside, of course, and it's returning that function. The decorator then, it's basically doing this thing, but passing the original function so we don't lost it to this throw function. Because when we do this, the function add, as it was defined here, is completely lost. There is nothing else referencing it, and we cannot get it anyhow again, right? So in this case, what we're going to do is, instead of just losing it, we're going to pass it as a parameter to throw function so we don't get it lost, okay? Basically, this is going to be the same behavior as we have in the decorator. We are just wrapping a function inside other function and replacing what we believe its original function with the result. I'm saying functions too many times. I'm going to change it because it's going to get kind of crazy. Let me rephrase it. Let's get a read of this throw function and go back to the only int arguments. What we're going to do then is we're going to rename add with the result of only int arguments, but we will be passing add so we don't get it lost. Okay, so now we believe that add, when we invoke it right here, we believe that add is this, but actually add is new f. Okay, we are passing add so we don't lost it, and we can actually make use of add. So for example, instead of doing only int arguments, we could do something like make this decorator a logger, right? So let's do something like about to invoke the add function. And now we're going to return the add function with A and B. So let's run it. And you see that I think I'm invoking add, but actually invoking this function. What does this function do? It's just printing something, and then it's running the actual function that I hope to run, add. Okay, so let's go step by step again. I am defining the original function. I am renaming it, right? And I am assigning the name add to the result of this other function, only int arguments. The only int arguments function is getting past the original add function so we don't lose it and we can keep a reference. So in this case, in this line, f is basically similar to add. Then we return new f, right? We return it. So what we get here, the result of this function is actually new f, right? It's returning new f. So we could say that add is basically new f. What is new f? It's just a function that runs a print statement or prints something out on the screen and then runs the original function that I'm expecting to run, in this case, add. And that's the expected behavior that we are seeing right here. We're seeing the result of add. Let's use another number. This should be 12. We're seeing the result of add, but previously we see the log message that we want. Again, this new function is free to do whatever it wants to do. So it could be a troll too and do something like a minus b. And here I am having something completely different. Instead of adding these two numbers, I am subtracting them. So this function newf is free to do whatever it wants to do. Of course, we are not going to do these all the time. We just have the freedom to do it. And as we write our decorators, we will choose the best thing to do right here.
I have a question.
Please go ahead. Yeah.
So on line 12, not the first add, but the second add on the right-hand side,
Yeah.
it does not have any input. So how does new F know 9 and 3 are A and B?
Because right here, we are just passing along functions. So what you have here is that there is no 9 and 3 in this line. There is nothing. Up to this point, there is no parameters ever passed to this function. And basically, what we are having is def, let me put it up here, def new f a and b, right? And we are doing new f here without any parentheses. So basically, we are renaming or changing the value of add to point now to new f. Okay, and again, if we are saying, let's keep it in this way. Actually, let me change this. We have here, let's forget about this for a second. Do you guys remember the concept of an interface? An interface basically documents what gets in and what gets out of a function, class, method, or any component we have in our code. What's the interface of the add function? What does get in for this function? We could say that the add function, the input is two numbers. A, we're expecting the parameter A and the parameter B. And the output is a final result, Z, let's call it, which basically it's the sum of A plus B. Now, I'm asking you from this new F, what's the interface of new F? It's receiving the same things, A and B, and it's returning, not in this case, but in this case, it's just returning the same thing as add was returning. It was also Z. So the interface is the same one. So something that you guys will see is that the interface of the function that you have here should be compliant with the interface that you have in your decorated function. That's a must, because if somehow the new f function, and let's go back again to the example with the decorator, if somehow new f receives a different type of arguments, let's say it's just receive one parameter named x, the invocation of this function, sorry, the storm is hitting things. In this case, the invocation of this function will break. Because as you see here, new f takes exactly one argument x, and I am invoking it with two arguments. Again, when I think that I'm invoking add here, What I'm actually invoking is new f. Can it make sense?
Yeah, thank you.
So again, step by step, let me do it one more time. We have our original function add. We are completely changing what we believe add points to. In this case, we are changing add to the return value of only int arguments. We're executing this function. We're getting inside here. We are passing add as a parameter to only int function arguments, so we don't lose the definition of this function. F now, of course, becomes only f. Maybe it's clear if I do something like f equals add. F in this case, of course, is the add function, so I haven't lost the function, the original function, and I'm returning new f. So basically here, I get assigned new f. Now, when I actually, and we are done, right? Let me comment this out. We are done. Now, the only thing that happened is that add was replaced with new f. That's the only thing that happened. Now, let's actually execute it. Let's run this line. What happens? I'm executing add with 9 and 3. I'm actually executing new f with 9 and 3. So basically, I'm going up here. Well, let me put this back as it was. I'm executing this line. I'm executing this line, the one that prints. And then I am forwarding, or I'm just executing the original function as I had it. The interesting thing here is that even though I have already completed this part, this function still remembers what add was, and add is not lost. You guys follow me? Make sense to people? Guys?
Yep, it makes sense.
Cool.
Santiago, I have a question.
Yeah.
How can we reference to the older original add function after we have executed line number 13?
Because it's an interesting question and it's related. I don't know if you guys have ever heard about closures.
Okay.
Closures. It's something usually related to JavaScript, but it happens in every other programming language, and basically means that I have passed. Remember, these things add only in arguments f. These are just names. The actual code is located somewhere in memory, right? So when we do add parentheses 9.3, we just want to execute this piece of code that is stored somewhere in memory, right? So when we invoke this function, and we pass add as the value of f, right here, this function is, this code gets all replaced, and new f here knows that it has to execute the small piece of code linked to the add function, and that's it. Once this is run, it's like the code is frozen and you have that reference to the actual original function, right? So
okay.
The important thing is as long as you're not losing the link to or the, how to say, the reference to this function, you're fine. We are not losing it because we have defined here. We are renaming it here, but before renaming it, we are invoking this. We're passing add, and you are referencing it right here in F. So it's not lost. You have control.
Okay. But can I use original add function later somewhere in my code? If yes, how?
Can you use it where?
Original add function sometime later in my code.
No. Once this line is executed right here, line 14, add as you knew it is gone.
Okay.
Completely gone.
Got it. Thanks.
So guys, I'm going to show you something kind of magical, and this is basically all the fancy stuff regarding decorators. Only in arguments used as decorators is basically the same thing as using this line. Adding this thing here is exactly the same thing as this. Let me comment this out, and we're going to run it, and you will see that I'm not lying. See, same result. Let me put it back again. Run it. Same stuff. Okay, so basically when we decorate something, what we are doing is just renaming not renaming, reassigning the name add to something else returned by the decorator. And that's something else we have control, and we can do whatever we want. So let's get ahead and change this as it should work. Let's add a few tests, right? So we want this thing to return 9 and 3, and we want this, for example, hello world, to fail, right? Right now, let me put one step in the middle. Let's do invoking add with params, and I'm going to give you the parameters here. They're going to be A and B. Okay, so let's comment this one out. Invoking add with params 9 and 3, and the result 12. And now we're going to run the second line. Invoking add with params hello and world, and this is the final result. I have something hard-coded here. Basically, I am using the name add when this decorator is, we could say, generic, right? It's not tied to add. I could place this decorator to any other function that I want. So for example, let's put a function multiply. Let's change this, and I want this to behave in the same way, right? I don't want it to be always tied to add. How can we change it? As I told you before, in this case, F is basically add. And as you guys, I'm sure you remember, functions are objects in Python, and they have arguments and attributes. So for example, the function add has, let me comment this out, an attribute name that I can access. The name of the function add is, of course, add. Let's run it again. Right? So I will be able to access all these attributes, right? All the attributes inside the add function inside my decorator too. Of course, makes sense. So I will just do something like, I'm going to decorate it again, and I'm going to do something like, let's do function name, param1 or p1, p2, and let's put a few names here, and let's do function name, it's equals to f.name, and p1 is equals to A, and p2 is equals to B, to put this in the same line to make it shorter. And here we go. Let's run it. Let's run this one. Invoking add with params, and now let's invoke multiply. Let's do 5. I'm running it, and we have it. Invoking add, invoking multiply. Okay, so now we could do something like, let's go back to our original idea now. Let's just allow integer arguments in our function. So instead of just printing this stupid message, what we're going to do is something like if type of A is not an integer, or the type of B is not an integer, we're going to erase value error and if everything goes well, of course, we're going to come here and this is the final result executed. Make sense? So now I'm going to just execute it. This example should worked 12, and now I'm executing this other example, and we should see, of course, this error message in screen. See, value error, only int arguments allowed. Make sense? Any question?
Santi, I have a question.
Yep.
So let's say you wanted to keep the add function as it was before the decorator, but you want to define another function, let's call it add integers, and there you're going to use the decorator and the add function that you defined before. So it's going to look like add integers equals add, and before that line, you use only int arguments. Is that going to work the same?
Can you type it here?
Yeah, let me go to the link. Is it on Slack?
Just pasted it.
Oh, okay.
We could get rid.
So it's like remove the decorator from the add function.
Yeah.
Yeah. And now put it below the function.
Yeah.
And just call another function, I don't know, add integer equals add.
Add integer equals add.
Yeah, and above that, put the decorator.
No, this is not going to work because decorators need to be, of course, in the definition of a function. What you could do is basically, if you don't want to lose the reference to this, you can do a completely generic function, and here just do something like return add. Well, basically, if we are sure, we can just use the same definition, right?
Mm-hmm. Okay.
So now this one is decorated and this one remains the same.
Okay, awesome. So you need to really define a new function.
Yep.
Okay.
Exactly. Of course, if you want to do it in just one line, you can just do it without the decorator syntax and just do something like, right?
Oh yeah, yeah, makes sense.
Completely.
That's gonna be the same as the other one.
Yep, exactly. So guys, from now on, decorators, whenever you see a decorator, this thing, and you're having troubles with it, it's just, remember that it's just a syntactic sugar to mean this. Add equals only in arguments of add. Whenever you are debugging a decorator, this is basically the behavior created. Okay? So for example, if we would like to pass parameters here, we could say something like, for example, we could do something like only in arguments, let's change it, and now it's going to be only numeric arguments. Numeric arguments. And we want to say something like integers. Yeah, we do want them. Floats, no, we don't allow them. So basically we want to change it in this way. What is happening here? We are, and check this out, the actual execution of this thing as a not decorated definition would be invoking only numeric arguments with these parameters And to this thing, we invoke it again with the add function. It's basically the same. So what we're saying is that we just have to change here integer float, and then we have to like create a new function just do this. See, it's kind of crazy, but let's see if it works. It should be, this should be, yeah, the behavior that we're expecting. So let's see, 9.3 again. We run it. It's the same behavior. Of course, we could use this thing here. So for example, we'd say something like if integer, that means that it's, we're going to have something like types allowed. We're going to do list if types allowed is, no, if integer types allowed, we're going to add int. If floats types allowed, we'll also add floats. By the way, let me change this to this definition and it should fail. See, because it's just accepting integers. We're accepting floats too. Let's put it through. And now, well, we'll do something like if type of A not in types allowed, or type of B not in types allowed, then we would raise the exception. Well,
shouldn't you change line 8 to be float singular, maybe? I think that's the...
Yes, you're completely right. Thank you. There you go. See, it works. So, of course, it's super ugly. Please don't follow my example here. But the idea is that I have what people usually refer to a decorator factory or a like configuration decorator, right? I can set my own configuration of in the decorator. By the way, this should work in this way. And again, whoop, false. This is true. Again, I am just managing functions, returning functions, returning functions, returning function. That's basically it. Any question?
Can you actually go through? I'm still kind of confused why integer equals true, floats equal true is an input to the only numeric arguments decorator, and also add is also an input to decorator. I'm still following the.
Yeah. So again, this is the final result that we want to run. But as I told you, when we do this, we are basically doing add equals to only numeric arguments, whatever we had. Remember when we did only int arguments? This was our original decorator. I told you that doing this was the same thing as doing add equals only int arguments with add passed as a parameter. So now I just have to replace only int arguments with this completely. Just copy and paste it to understand it. Is replace only int arguments with this. What does it become? This. See? And now we have two executions of functions. Separate these parentheses. You're first executing this thing. Oh, first remove the @ sign here because it's going to fail. First, we execute this thing, and to that thing we pass the second time. So how does this work? If you guys read it line by line, you're basically executing this thing first. Let's see what it's returning. So we execute this function, only numeric arguments. And what is it returning? The actual decorator. To the actual decorator, so we can replace all these things here for actual decorator. To the actual decorator, now you pass the function add. Right? We have the actual decorator, we pass the function add. Same thing as before. F is equals to our function add. By the way, right up to this point, we have the same thing as with only in arguments. So we're doing actual decorator, now it's add. What does actual decorator returns? Its actual decorator is here, it's returning new F. So we basically know that this becomes new F. Okay, so it's like we are replacing the execution of its function with, let me go back, with the, one second, there you go, with the result of each function after it's executed. I know that this might be hard to follow because there are so many functions nested. We have 3 functions. We have 2 functions inside one. We have 3 functions in place, and that's all invoked in the first time. So we have 1 function invocation plus the other function invocation. Of course, it's kind of crazy. How can we refactor this? We could use classes instead of functions. As you guys remember, classes have magic methods that let us execute them as functions. If you guys remember our lecture from magic methods, about magic methods, right? We saw that classes have a lot of magic methods we could use to like change the interface of them. One of them is the call method. If we implement this call method, we can make a function, a class, behave as a, let me create a new file, dec class.py, as a function. So let me show you something. No, let me try it 1 second. I think I am screwing up here. Yes, I am. Sorry. Yep, work, sorry. There we go. So basically what I'm doing, sorry for the long time, I am creating an object that now behaves as a function. Okay, there is no magic here. If you have an object and you use it as a function, you're basically invoking this parameter right here. Sorry, this method right here. So what we can do, if we want to go back to our previous example, let me copy as it was, and let's rewrite it here. If we want to use this thing, what we could do is make this part behave in the init method of our decorator in a class, and the second part in the argument. So we're going to do something like only numeric arguments. When this only numeric arguments class is instantiated, again, this is just a regular object. We are passing these two parameters, so we have to define it in the init method. Right? And now when this thing is invoked, it will just receive the original function, f. And here we can put our logic, print, executing the function, return. Again, the same thing as we had before. Oh, sorry, I forgot the wrapped one. Let me see if this thing runs. See, works in the same way. So basically, we are, instead of using a 3-level function, we are just using a simple class. We manage this part, the configuration part, in the init method, and then we manage the decorator as we used to do it with just one nested function inside the call method. So usually these type of decorators that need to be to have some configuration are better managed through the usage of classes. Less verbose, reads better. Once you get used to this call thing, it just falls through. Make sense? Any questions?
Yeah, I have a question.
Yeah.
I mean, this is like, well, when you're like writing a program to do something, when do you start thinking about, hey, this is a really good time to implement the decorator instead of implementing it differently?
Well, that's the key point. What is implementing it differently? You will find yourself doing something like if A is different, if type of A is different than int, or type of B is different of an int, then raise, right? And then you want to write other function. Maybe you want to write the multiply function, right? And you find yourself doing the same thing over and over and over again, then you just put it in a decorator. Decorators are to functions what inheritance is to classes. Okay, so when we want to abstract something away, or when we want to reuse some functionality with objects, we create an object hierarchy, right? A car is a vehicle is something, right? When we want to do that thing with functions, we use decorators. Basically, we are refactoring the code that is repeated in some way, and we are putting it in just one shared place. Make sense, Chris?
Yeah, that makes sense. Thank you.
You're welcome. So guys, this is today's project, so we can just get it done. We right here, that's today's project. What you have to do is just write a set of decorators, all right? We have a timeout decorator that when it's applied to a function, if the function takes too long, and here we have some configuration for the decorator, so heads up, try to do it. Actually, as an exercise, you could do it first as a function and then as a class. If this function takes more than the time specified here, this decorator should fail, okay? Not fail. This decorator should like make this function raise an error. If of course it doesn't take too much, just the function should be executed as it is. Then we have the debug decorator, that this debug decorator actually has some configuration also. If you guys check the tests, you will see sorry, wrong directory, tests. Test decorators. Test debug. We can do it without any parameters, right? And then we can actually send a logger, pass a logger here. And we have also count calls, right? It will just, whenever you are invoking the function, you will have like a register of how many times a function was called and a few other decorators, okay? They're all really well tested, so the interface is right here. For example, in this case, if we invoke this function, it shouldn't raise an error. In this case, it should raise an error. So it's basically just a set of separated decorators. They will work each by themselves. They are isolated, but they will test a different thing per decorator. Questions?
Maybe a simple question, but when you're deciding to use either a class or a function or to make a decorator, apart from the case that you're making a factory decorator, and that's more verbose, is there other reasons that you would choose one over the other? So maybe a class might be less efficient or take more time or something like that?
To create one of these decorators that have some configuration?
Yeah, so you said that for the decorated factory right here, that it's pretty verbose, and that's understandable, and so it's better to use a class, right? Because then it's easier to read and stuff like that. But is there, other than that, a difference?
No,
like maybe one's faster or
no?
Okay.
And that statement about being better, it's of course my opinion. I believe these will be easier to read than these other thing, but of course you can find decorators written in this way also. It's just a matter of taste. I believe this reads better.
Okay, all right, thanks.
Okay, so questions? Martin is creating the groups right here, so just get to work. All right, guys.
Thanks.
Bye.
Yeah.
Thank you. Bye.
See you.
Thanks.